All right, today we are going on a journey. We're going to crank up the cosmic thermostat and go on a hunt for the absolutely hottest places in the entire universe.
So let me just start by asking you a question. When you think cosmic heat, what's the very first thing that pops into your head?
For pretty much everyone, the answer is our sun, right? I mean, it's a gigantic, blazing ball of gas, the engine of our solar system. It just feels like the obvious champion of heat. But here's the cosmic punchline. In the grand scheme of things, our sun is, well, it's barely even warm. You know, to really appreciate the insane temperatures we're about to see, we need a baseline, a starting point. The sun's core is a furnace of nuclear fusion, hitting about 15 million degrees Celsius. Now, by our standards, that's impossibly hot. But in the universe, that's just our starting pistol. So let's start climbing the universe's thermometer. You're going to see just how quickly we leave our home star in the dust. Almost immediately, we find things that make the sun look like an ice cube. Take neutron stars. These are the super dense collapsed cores of old stars. Their insides can get up to 100 million degrees. Or get this, when whole clusters of galaxies smash into each other, the shock waves heat up the gas between them to that same insane temperature. Just let that sink in for a second. We're already at temperatures more than 6 times hotter than the very center of our sun. And believe me, we are just getting started. Okay, our next stop takes us to a place where gravity itself becomes the ultimate heat engine, the chaotic, swirly mess right at the edge of a black hole. Now, the key thing to understand here is that the black hole itself isn't hot. All of this mind-boggling heat comes from the stuff that's getting violently torn to shreds as it spirals down the drain. This swirling vortex of doom is called an accretion disk. The gravity is so intense that it causes gas and dust particles to rub against each other at unbelievable speeds. It's basically the universe's most extreme case of friction burn, and it generates temperatures well into the hundreds of millions of degrees. But even that gets left in the dust when we look at one of the most violent events the universe has to offer, the explosive death of a massive star. So how does a dying star create so much heat? Well, it all starts when a giant star runs out of fuel. There's nothing pushing outwards anymore, so gravity takes over and wins, causing the core to collapse on itself violently. This triggers a catastrophic shockwave that just rips the star apart, releasing a torrent of pure energy. At the very peak of this implosion, the temperature reaches a truly astonishing 3 billion degrees Celsius. We just made the leap from millions to billions. This is the hottest naturally occurring event we've ever actually observed. So, what could possibly be hotter than a supernova? Well, it's time for our final 2 contenders. This is the ultimate showdown, the hottest temperature ever created by humans versus the hottest temperature in the entire history of the cosmos. In one corner, we've got a bizarre state of matter called quark-gluon plasma, something scientists made right here on Earth. And in the other corner, we have the theoretical temperature of the universe in the very first moments after the Big Bang. Over at the Large Hadron Collider, scientists smashed heavy ions together with so much force that for a tiny fraction of a second, they actually broke apart protons and neutrons, creating this kind of subatomic soup. It's called quark-gluon plasma, and it's thought to be what the entire universe was like right at the beginning. And the temperature they recorded, it's just brain-melting. 5.5 trillion degrees Celsius. That is the hottest temperature humanity has ever detected, ever created. An absolutely monumental achievement. But even that unbelievable number has been beaten. To find the true, undisputed champion, we have to travel back in time. 13.8 billion years ago, to the moment right after the Big Bang. In the very first microsecond of its existence, physicists believed the universe was a searing inferno of pure energy, reaching temperatures of over 10 trillion degrees Celsius, and probably much, much higher. It's a temperature so extreme, it's almost beyond our ability to comprehend. Okay, after that absolutely blistering tour of cosmic hotspots, what's the big takeaway? What's the fundamental idea that connects all of these unbelievable temperatures? The really crucial thing to get is that cosmic heat isn't about fire like we think of it, not at all. It's the direct result of physics pushed to its absolute limits. It's created by the crushing pressure of gravity inside a star, the insane friction of matter being accelerated around a black hole, and the raw, untamed power of nuclear processes in a supernova or the Big Bang itself. From our own sun's core all the way back to the dawn of time, we've explored temperatures that just defy imagination. And it really makes you wonder, doesn't it? If these are the incredible extremes we already know about, what other, even more intense things are still hiding out there in the cosmos, just waiting for us to find them?